We're going to work on Nathan's project to analyze what drives the delivery cost. And he's got three variables: the miles, the number of packages, and the number of locations. And he wants us to do a regression for each of the three individually, using 18 weeks of data to see what we get and then interpret it. So let's have a look. So let's go. Our data analysis has already been installed, so we have regression. And the Y is the outcome, in this case, delivery cost. And we'll just start with miles. And I did put the label in the range, and we can pick an output range. All right. So let's evaluate this one, this number of delivery miles. So the first thing we want to look at is the R squared, or the adjusted R squared. They're very close. And this is above 0.3. Anything below 0.3 is considered noise, so this is a good fit. Is the slope significant? So that is the variable portion of it based on the miles. And so we're going to look over here at p-value for that. And the p-value is below 0.05, so the slope is significant. Economic plausibility is, does it make sense? Does it make sense that the more miles you drive, the more your delivery cost goes up? Yeah, it does. In terms of the regression equation, what would it look like? So here, it would be delivery cost. In this case, your author's calling it Y, equals 3.48, rounded, times miles, plus the fixed cost. In this case, $21,926. So Y equals 3.48x plus 21,926. I think your book wants dollars and cents, so it would actually want the 26.18 rounded. There you go. When you run all three of these, the question is, which one would you prefer if you just want one independent variable? And you would pick the one with the highest R squared, because that's explaining the most variance. So this is explaining about 59–60% of the variation in delivery cost. I don't know what the other two look like, but if this was the strongest one, we would pick it. So let me know if you have any questions.